Okay, this is to help you do your homework for the exponential logarithmic application section. First question, 2012 populace was 6.66. Exponential growth rate is that. I'm just going to automatically change that to this just so I don't forget. Find the exponential growth function. Oh, okay, so that's you plug in the initial 6.66 e to the k, that's this number, 0.0297 times t. Here's our growth function. Population of the city in 2018, so that's 6 years after. So I need to use that formula there. I'll put it over here. P of t equals 6.66 e to the 0.0297 times t. So the population after 6 years, is that what t is? Yep, 6 years, is going to be 6.66 e to the 0.0297 times 6. And when you do that, it should come out to about 8. We have to round to one decimal place. We'll call it 8.0. The population of the city will be 9 million in about how many years? Oh, so I need to use the same formula. And this time they want to know when it's going to be 9 million. So that'll be the n number, this number. Okay, so this will be 9 is equal to 6.66 e to the 0.0297 t. Now I need to isolate this part, so I'll divide both sides by 6.66 equals e to the 0.0297 t. Change from exponential to log form. So it'll be log base e of 9 over 6.66 is equal to 0.0297 t. Then divide both sides by that, the 0.02. So I'll have ln of 9 over 6.66 divided by 0.0297. Notice I didn't actually divide that because it would have come out to a decimal. Might as well leave the number like that. And in decimals, you can do that. So the time for that one, it should come out to being about 10.1 years. 10.1 years. Okay, the last question. What is the doubling time? Oh, okay, well, here's our general function. 6.66 e to the 0.0297 t. And they want to know when it's doubled. So I just take this and I double it. So it'd be 13 point, I think I could times that by 2 in my head. 12, 1, 13, there, 13.32. So I want to get to 13.32. I'm starting at 6.66. And my growth function is this, t, same thing as always, divide by 6.66, so I'll get 2 is equal to e to the 0.0297 t, change to log form, log base e of 2 is equal to 0.0297 t, divide both sides by that, so I'll have a ln of 2 divided by 0.0297. So if I've done that right, I think I have. This is, it should be about 23.3 years before you double your population. Okay, question 2. Country A's growth rate 4.8%, so 0.048. Population, this is what it starts at. Land area of the country is 10 billion square yards. Assuming this growth rate continues and is exponential, after how long will there be one person for every square yard? Sort of a funny way of asking it. Just how long will it be until you have that many people? So this would be P of t. After how long time? Good. So let's do our formula. P of t equals P0 e to the kt. So P of t, that's at the end, 10 billion. Is that enough zeros? No. Equals, starting with 4,099,000 e to the k, 0.048 times t. Good. So now I want to isolate this. So I'll divide both sides by that number, 409,900. So these cancel. Then I'll change it to log form. So it'll be log base e of 10 billion over 4,099,000 is equal to 0.048 times t, and then divide both sides by 0.048. So you'll get ln of this 10 billion thing. Don't forget all those zeros. Over this is equal to t, and I have to divide that by 0.048. So the time I'm getting is 162 years. It's a pretty good growth rate, 4.8%. Okay, radioactive element carbon-14, half-life 5750. We did one just like that in the video. Scientists determined that the bones from a mastodon had lost 67.7. Lost, keep that in mind. How old were the bones at the time discovered? So the first thing you have to do is figure out what K is. So they give you the half-life, so let's just plug that into our formula. P0 e to the kt. So say I start with 10 grams of stuff, and then I'll wind up with 5, half of that. E to the k, we don't know, but the time we know is 5750. Divide both sides by 10, so you get 0.5 is equal to this, and then change to log form, log base e of 0.5. Are you getting good at that? If you answered yes, that's good. Okay, then this is the ln of 0.5 is equal to k times 5750. Divide both sides by that. So you get ln of 0.5 over 5750. So our k value, if I remember, was 0.0001205. I think that was the right number. Okay, so that's k. That's the decay constant. Now I can use that in this next question because they say how old are the bones? Okay, let's see. They give me a percentage that has lost, so I assume that I'm starting with 100%. If they lose 67.7 of their carbon, that means they're winding up with 33.3% of their carbon. Okay, e to the k, I know k. I think that was supposed to be negative. Negative 0.0001205 times t. Same way, divide everything by 100. 0.333 equals e to the negative that. Change to log form. Log base e of 0.333 equals negative 0.0001205 t. So ln of 0.333 divided by negative 0.0001205 has to equal t. And if I just go with my answer key and what they think the question should say, they say this thing is 9,375 years old. It's a good one. I like that one. So you find K and then you use K. Next question. The data in the table shows the percentage of adults in the country married declining. Assume that the percentage of adults who are married continue to decrease according to this model. Complete parts A through C. So they want to know what K is. How do you find that out? Oh, it says use the data for 1960 and 2012. Oh, okay. So 1960 So this would be my initial amount. And then my final amount would be this one. This would be P of t. And the time difference between those would be 52 years. There, yeah, I could do that then. So P of t equals P0 e to the kt. P of t at the end, 40.7. P0 at the start, 69.5. E to the k times 52. Divide both sides by 69.5, so you get 40.7. Divide 69.5 equals e to the k times 52. Change to log form. Log base e of 40.7 over 69.5 is equal to k times 52. Divide both sides by 52. Have we done this process enough yet? Okay, so it'll be ln of 40.7 over 69.5 equals k, and I have to divide this by 52. Let's pull out decimals and figure that out. Okay, I'm going to move decimals around a little bit, but let's start it off right there. Okay, so I'm going ln functions, miscellaneous ln 40.7, 7, divide 69.5. Good. Go over and then hit a bracket and then divide that by 52. There we go. And our k value came out to be negative, and that makes sense because it's decreasing. So it'll be negative 0.01029-ish. That's what k is. All right. Let's get rid of decimals for a second. Now, so they asked us what k is. So k is negative 0.01029. Write an exponential function that describes the adults. Okay, so P0 would be our first one, 69.5. And then e to the k, our k is negative 0.01029. Then they say estimate the percentage of adults who are married in 2015 and then 2018. Okay, so to do that, let me go down a bit. So my formula is P of t equals 69.5 e to the negative 0.01029 t. So they say 2015. So how many years is that? 2015, so it'd be 40, it'd be 55. Be 55 years. 55. So the population or the percent of adults would be, we're looking at 55 years. So 69.5 e to the negative 0.01029 times 55. And make sure you put that in bracket up there. So my answer key comes out to, let's see what that comes, 2015, 38.2, I think. 38.2. And then in 2018, my answer key says, and you can look that up. Well, maybe it's 39.4. I'm going to decimals it so I know for sure. Okay, 69.5. Uh-oh. I gotta be able to see it. 69.5 e, so, oh no, I don't need functions. I need ABC. E to the, in brackets, negative 0.01029, yep, times 55. bracket. 39.46. So what they say 39.4? 39.4, 39.5. 39.4. And then if you do the next one, this one, it comes out to 38.2. 38.2. Okay, then they say, get rid of this again. Then they say, at this decay rate, in which year, so we have to solve for t, will there be 32%? Oh, this is good. So P of t equals P0 e to the kt. So I'm starting with, what am I starting with in 1960? 69.5, that's my P0. So 69.5, and they want to know how long it's going to take till I'm down to 32. E to the K, 0.01029 with a negative, don't forget my negative, and T, and that's what I'm solving for. So divide both sides by 69.5, it's 32 divided 69.5 is equal to E to the negative 0.01029 times T. Change from exponential to log form, log base E of 32 over 69.5 is equal to negative 0.01029 T, and then divide both sides by that. So I'm going to get the ln of 32 over 69.5 divided by negative 0.01029. And my answer key for that one says it's not going to happen till the year 2035. Okay, next question. In a town whose population is 4,400, you get a disease, sort of topical question. The number of people infected T days after the disease is given by this function. Complete parts A through C below. How many initially infected with the disease at T equals 0? Oh, we can figure that out. So N at 0, I'm just using this formula right there, is equal to 4,400 divided by 1 plus 17.4 e to the negative 0.5 times t, which would be 0. Okay, so 0.5 times 0 is 0, e to the 0 is 1, and so this would be the same as 4,400 over 1 plus 17.4, because this would just come out to 1, or 4,400 divided by 18.4. Okay, my answer key for number 5 says 239. So initially you've got 239 people infected. And then they say, okay, how many infected after day 2, 5, 8, 12, 16? I'm going to maybe pick 5. I'll just do one of them. So I just need to put a 5 in everywhere there's, just like I did with 0. So N5 equals 4,400 divided by 1 plus 17.4 e to the negative 0.5 times, I'm doing 5 after 5 days. Okay, let's fire up decimals. I'll just put it right there for now. So 4,400 divide, I'll maybe put this in brackets. 1 plus 17.4 e to the, and then I'll put this in brackets too, bracket negative 0.5 times 5, bracket, bracket, and go over this way and hit a bracket maybe. There we go. 1811.98, call it 1812. So after 5 days, there'll be 1,812 people infected. And you can do the rest of those. They'd be all very similar. At the bottom there, it says, use this model. Can you say whether all 4,400 people will ever be infected? And that's a good question, because in order for this to be, to have everybody infected, it would have, this bottom thing would have to be 1. This piece here would have to turn out to be 1, so that you'd have 4,400 divided by 1. But the problem is this here, I could never get to be 0, because you'd have to have 1 plus 0. You could never get that to be 0. So realistically, it could never happen. So it could get close, so I'd be putting this answer. You could get close to it, but realistically, it would never get there. Okay, next question. According to Newton's law of cooling, body, so this is the initial temperature, is placed in surroundings, or T0. The body will either cool or warm to temperature T, so this is at the end, after so many minutes. So there's our formula. So our temperature at the end, after a certain amount of time, is T0, that's the surroundings, plus temperature of your body, minus T0 times e to the negative k, I guess we don't know what k is, times t. So that's my formula. So the question says a chilled jello solid with temperature of 46. So that's the body. That's this 41, or T1 thing. So this is 46. It's taken from the fridge and placed in a 68-degree room. So that's the temperature in the surroundings. So that means this is 68 and this is 68. E to the negative, well, I guess I don't know all that stuff yet. After 15 minutes, that'll be my time. The temperature of the solid is 51. So that's the end temperature over here. Oh. It looks like I know everything in this formula except for K. Well, that's good. Let's do that. This looks like a little bit more work to find out K, but so I need to isolate this first, and then just this, and then change the log form. So let's subtract 68 first. Subtract 68. So it's negative 17 equals 46 minus 68. I think that's negative 22. E to the negative k times 15. Everything's looking dandy so far. Divide both sides by negative 22. So I'll get positive 17 over 22 is equal to e to the minus k times 15. I've got it right where I want it. Let's change it to log form. Log base e of 17 over 22 is equal to negative k times 15. So the ln of 17 over 22 divided by negative 15, that'll be equal to my cooling constant. Okay, enter decimals. And let's do that. So ln functions. Whoops. No, I don't want that kind of function. Function miscellaneous. Ln 17 divide 22. Oh, that's what's happening. If you hit it too quickly, it doesn't register. Bracket divided by negative 15. There. Okay, so my K value, my cooling constant is negative 0. Oh, it's not negative. 0.017188, call it. Okay, so that's the constant, but did they actually ask us that? Oh, they said how long, what it's going to be after 20 minutes. Well, I needed to find that K in order to find out the next part. So let's use the same formula. So I'm starting with the same jello. So the jello is starting at 46. minus, and let's see, find the temperature. Use me find the cell's temperature after 20 minutes. Oh, yeah, so we take it out at 46 and place it in a 68 room. Okay, and the room is 68, and then e to the negative, and the k value is 0.017188, and the time is 20 minutes, equals t after 20 minutes. Okay, so now let's just plug that into decimals, if decimals will work for me. Yep, so 68 plus bracket 46 minus 68, 8, doesn't like that line. Okay, 68, bracket, e to the, in brackets, negative 0.017188 times 20, bracket. 52.4, call it 52.4. They say round to the nearest integer, we'll call it 52. So this will be after 20 minutes, the jello will be warmed up to 52 degrees Fahrenheit. I would still eat it at that temperature. Okay, question 7. Following the birth of a child, parent wants to make an initial investment that'll grow to 40,000. Interest is compounded continuously. Oh, continuously. So if it's continuously, I'm using the same formula. P0e to the kt. Okay, 7%. Wow. What should the initial investment be? So this time we're looking for P0. Okay, so there's our formula. P0 is what we're looking for. E, the K will be 0.07. The time, so 19 years is how long we need that investment to go in for. And we want the investment to be $40,000 at that point. That'll be interesting to see how much money you have to put in. Okay, so for this, if I'm wanting to solve for that, I just have to divide both sides by this. Times 19. Divide e to the 0.07 times 19. So P0 is equal to decimals. Let's see my numbers here. So 40,000. Good. Divided by E to the, in brackets, 0.07 times 19, bracket. So $10,579. And they want to round to the cents. Okay, so put in $10,579.09. And if you do that, then after 19 years, your money is going to grow to 40,000. That's a pretty good investment. Last question. Given that y equals a times e to the x, a is greater than 0, take the natural log on both sides. Then let y equals ln of y. Consider y as a function of x. What kind of function is y? So I need to solve for y. So I have y is equal to a e to the x. And they say take the natural log of both sides. So let's take this side, ln of y, and then this side, I'm taking the ln. Okay? All right, so then they say ln of y is equal to capital Y. So this is a capital Y. And then this over here, this is the product rule. So I can call it ln of A plus the ln of e to the x. And then this x is a power, I can bring it out front. So ln of A plus x ln of e. That's equal to y. So if I just look at x's, oh, and ln of e is just 1, right? So y is equal to ln of a number plus x. So they want to know what kind of equation it is. Well, I look at the x and there's just an exponent of 1. That means it's a linear. It'd be cubic if I'd have wound up with a 3 there, or quadratic, I'd have wound up with a 2 there, it would have been quadratic. But here there's just an x, plain old x, it's a linear function. All right, hopefully that helps you with your homework for this section.